So, a warm welcome to the 5th session of the 3rd module of signals and systems. We had begun to look at a sine wave being sampled in the previous session, and we saw that if you sampled a sine wave uniformly, that means at points which are spaced with an equal spacing between subsequent points, between adjacent points, then the following question needs to be answered, namely, what are all the sine waves which would have those samples at those points? And we had answered that question graphically. In fact, we had answered it graphically for a specific instance, but the general principle becomes obvious from that instance. Let us take a couple of seconds to recapitulate what we had come up with as an answer. The answer was that between two subsequent samples, you could be losing 1 cycle or 2 cycles or 3 cycles or any positive integer multiple of cycles, and again for each of these possibilities of losing, you could either lose the whole cycle or you could just fall short of losing that cycle, which means that you could arrive at the next point either on the correct edge or on the wrong edge. So, for each positive integer possibility of losing a cycle, there are 2 additional possibilities as far as the sine waves that can contribute those samples are concerned. One where you come back on the same edge and one where you come back on the wrong edge. Now, what we said is that we need to write this down mathematically. Let us do that now. So, let us write down just one sine wave here, just that one sine wave that we are sampling, A naught cos omega naught t plus phi naught, and of course, we agree that omega naught is 2 pi by t naught. T naught is the time period. Now, where does the non-uniqueness come from? Of course, the non-uniqueness first comes from sampling. So, effectively, what is the process of sampling doing? The process of sampling is creating many other frequencies. So, let us write that down. What is the process of sampling doing? Sampling creates many ghost or monster frequencies, you might call them, which have the same samples at the same points. So, in other words, what we are saying is that you have many other frequencies, let us call them omega k, essentially A naught cos omega kjt plus phi kj, such that, of course, you remember we had said that j corresponds to the 2 possibilities of correct and wrong edge, and k is all the positive integers, essentially belongs to script z plus the positive integers. Now, what are these omega kj's and what are the corresponding phases? We need to write that down. So, where will these omega kj's come from? Well, they come from the fact that x of t, which is A naught cos omega naught t plus phi naught, when sampled at t equal to nts, gives you x, let us use square brackets nts, and the non-uniqueness comes from being able to add a phase to this. So, if you add plus or minus 2 pi kn here to the phase, k over all the integers and n also over all the integers. N is essentially the sampling instant, k over all the positive integers. You only need positive integers because you have taken plus and minus, and k has a significance now. K essentially denotes the number of cycles that you have either completely or almost lost. So, if you do that, you get A naught cos omega naught nts plus minus 2 pi kn plus phi naught, and we can take all this common. We could write A naught cos, well, let us take n common anyway, nts common actually, and you have omega naught here and then you have plus minus 2 pi by Ts times k and a plus phi naught there. Now, of course, you recognize that omega naught is 2 pi by T naught. T naught is the period. So, we can rewrite this. We can rewrite this as A naught cos. Now, we will take 2 pi also common. A naught cos 2 pi NTS in brackets 1 by T naught plus minus k by Ts, where k has all the positive integer values plus phi naught. Now, you will recognize that this expression here is representative of the cycles per second frequencies, which are all contributing these samples at these points, all possible cycles per second or Hertz frequencies. Now, let us look at the situation. You see, you will agree with me, one thing is very clear. We of course need to have more than one sample in a cycle. In fact, let us take an extreme case. Suppose I just took one sample in a cycle and I took the sample at the same location in a cycle. I would get the same sample in every cycle. There would be no way to distinguish between this and a constant. I would not know if the sine wave is of 0 frequency or the sine wave is of a frequency higher than 0, whether there is a sinusoid at all or it is just DC. Now, if I took less than one sample in a cycle, you are actually considering a possibility that you are almost losing a cycle. So, if we have agreed that we have not almost lost a cycle, you see, we have to, some a priori information needs to be there. So, if you wish to agree that you are not losing or almost losing a cycle, and that is the sine wave that you want to reconstruct, then the only choice before you is at least take 2 samples in a cycle. And we will definitely therefore agree that the time interval between samples must be less than the cycle time. So, going back to the expression here, let us identify the frequencies here. The Hertz frequencies are essentially 1 by T0 plus minus k by Ts, k equal to 1, 2 and so on. And of course, Ts is strictly less than T0. So, if you take the possibility, let us take for example, the possibility k equal to 1. Now, 1 by T0 minus 1 by Ts would be negative, because 1 by Ts is greater than 1 by T0. Now, we do not want a negative frequency. So, what correction can we make? Go back to the original expression. A naught cos 2 pi n Ts 1 by T0 plus minus k by Ts plus phi 0. This is the expression. But then remember, cos alpha is always equal to minus cos of minus alpha. So, cos alpha is always equal to cos of minus alpha. So, you could do a plus minus on the whole bracket here, and that means if you did a plus, it is as it is. If you did a minus, let us write that down clearly. So, if we take plus, we get the same expression. On the other hand, if we take minus, we get the expression. So, it would be minus. So, in that case, see here there is a plus minus and here there would be a minus plus. This is important. The phase is reversed. Now, let us take again more specifically for just k equal to 1, and let us use both minus and plus when it is convenient. So, let us take plus for 1 by plus 1 by Ts plus 1 by T0, which tells you the expression is A naught cos 2 pi n Ts into 1 by T0 plus 1 by Ts plus phi 0, and take minus for the case where we had a negative frequency, so as not to confuse ourselves with a negative frequency. And when we do that, we recognize the phase is reversed. Essentially, it is these two frequencies that occur at the loss of one cycle. So, when you are losing a cycle and then coming back on the correct edge, or losing a cycle, almost losing a cycle and coming back on the wrong edge. The same argument could be used for losing 2 cycles, 3 cycles and so on. But now let us take also to get a full understanding of what is happening here. Let us take the specific instance of the sinusoid that we talked about here, where you had a pi by 2 phase gap. So, what was the situation here? Let me write it down. In our example, in our graphical example in this discussion, Ts was equal to T0 by 4. So, essentially you would see 1 by T0 plus 1 by Ts is 5 by T0, and 1 by Ts, which is 4 by T0 minus 1 by T0, is 3 by T0. And in fact, that will make it very clear if you look at the graphical situation too. So, let us draw it again, just that part. You had a sample here and a sample here, there was a spacing of pi by 2 initially. This is the true sine wave. Now, the false one, losing a whole cycle, is where this went down, went through a whole cycle, but came down again on the correct edge. So, what is the situation here? You have 2 pi plus pi by 2, which means 4 times pi by 2 plus pi by 2, 5 pi by 2 spacing. And this is a situation of frequency 1 by T0 plus 1 by Ts, which is essentially 5 by T0 as we saw. And let me now draw the last one, where you had not quite a whole cycle lost, but you came on the wrong edge. What is the situation there? The situation there would be, in fact, I leave it to you as an exercise here. Draw the figure for this case. Verify the spacing to be 3 pi by 2 instead of pi by 2, which means the frequency becomes 1 by Ts minus 1 by T0, which is 3 by T0. I leave this to you as an exercise to verify the whole idea, both in terms of frequency and the phase change. We will see more about sampling sine waves in the next